nice even class, or yeah, even classes. All right, so this 6-2 section is going over parallelograms. Essentially, this whole section that we're about to go over is primarily just focusing on different quadrilaterals and stuff. This one, the notes-wise, pretty much just covers parallelograms, but I'm also going to go over stuff for all quadrilaterals because technically your assignment that you're going to be doing is going to cover all of that as well. This that I put over here on the notes is actually directly from Delta Math. If you want to see this without pulling up the digital notes, when you're in your assignment in Delta Math, the first skill that you do is literally just naming what the shape is. So they'll show you a picture and give you some stuff on the actual shape, and you just got to decide which type of shape it is and why. So if you want to see this, you just click on Show Examples in Delta Math, and this actually shows up. So if you don't want to pull up the notes to see that, just click on Show Example, and you'll be able to see it. But when you're working on this first section, where you're naming the different shapes, the really important part is understanding that as you go down this list from quadrilateral, trapezoid, and so on, it's just getting more specific, but technically all of these are quadrilaterals. And other than these two out here, everything down here would be considered a trapezoid. Although obviously when I look at this, the first thing that comes to mind is not saying, hey, this shape right here is a trapezoid. Well, yeah, I know that this shape right here is actually a rectangle, but it falls in the same category as a trapezoid because the only thing that distinguishes a trapezoid from any other quadrilateral is just the fact that a trapezoid means it has to have one pair of parallel sides, right? So as you work your way down these, it just gets more specific, but as I go up, all of these shapes at the bottom row, rectangle, square, rhombus, they're all fit in the same category as a parallelogram, right? These are just more specific descriptions of the type of parallelogram that it is. Okay? Same thing with trapezoids. So technically all of these shapes are trapezoids because they all have at least one parallel pair of sides. It's just obviously now, once I have two pairs, I can call it a parallelogram, right? Or if they have four right angles, I can call it a rectangle. Or if all the sides are equal, it could be a square or a rhombus, right? So these are just more specific descriptions as you work your way down that list. Now, one thing that you want to make sure that you understand when you're doing this on your assignment, when you're looking at these, the parallelogram and rhombus, a couple things you need to know is that the angles that are opposite of each other are going to always be equal to each other, right? So these angles are equal. Same thing would be for these two angles right here and here. The angles opposite of each other are always going to be congruent, right? So when you're doing your assignment, if they tell you that this angle up here, this red one, is 50, then that means that the other red one, the one opposite of it, is also 50. Or if they say this is 100, that means this one's 100. Okay, so anytime that you're looking at the angles on those, and it's the same thing for a rhombus, because obviously, again, a rhombus is still technically a parallelogram. So what works for parallelogram would work here as well. Okay, opposite angles are equal. Same thing happens for the sides. The opposite sides of these shapes are also equal. So like this side would be equal to this one. And if I go the opposite direction, this side over here would be equal to this side. Okay, so just make sure you know that, because again, when you do your assignment, it's going to ask you questions or show you an image, and you have to just decide which of those shapes it would fall under and why, and your reasoning needs to make sure that it's accurate, right? You don't want to just be like, oh yeah, I think it's a rectangle because it looks like a rectangle. I would say, oh yeah, this is a rectangle because it has, two parallel pairs of sides and four right angles. Right? So that would be your reasoning for picking that. So just make sure you read the answer choices when you do those. Okay, if you want to label this parallelogram up here, I'm going to just go through and label everything that's on here. So the first thing is just telling you the sides are equal, which we just talked about. So opposite sides are equal here and here. And then the opposite angles are equal, which would be P is congruent to R. And then you've got S is congruent to Q. Okay, so that's all they labeled there. This next piece, where it says that these are supplementary, if you forgot what that means, Supplementary means it adds to 180 degrees. So what that means is when you're looking at this example up here, right, when I compare angle R and angle Q, those are supplementary. They're next to each other, right? So I know that if I only knew that R was 50, I could solve for Q because I know it has to be 50 plus angle Q is 180. And then I just use that by subtracting to solve for Q. And it works the same way this direction as well. Any angles that are next to each other there, here, here, all of them that are next to each other, they're all supplementary to one another, right? So if they give you one angle, you could effectively solve for all of the angles by just using the fact that these are supplementary. Because once I know Q, right, again, let's say Q is 50. If Q is 50, R has to be 130, right? Because 50 and 130, that's 180. Well, as we already discussed, angle Q and S, they're the same. So if Q is 50, S is 50. If R is 130, P is 130. So by just knowing that one angle Q, I could solve for all of them. One of the skills in your Delta Math assignment, that's exactly what you're going to do. They're just going to say, hey, here's this one angle, solve for the other three. And that's all you have to do. You know the one opposite is the exact same number, so they're basically giving you one answer anyways. And then the other two angles, they just add with that angle that they gave you to equal 180. So you just subtract, get your answer, done. Should be fairly straightforward. The bottom part there is basically just saying if the parallelogram has a right angle, it's got 4 right angles. Well, as we already know from looking at this, right, if you have a parallelogram and it has one right angle, they all have to be right angles. That's because that parallelogram is actually a rectangle. One thing to note in your assignment, they will usually just call them parallelograms on like 90% of the questions, but just because it says parallelogram doesn't mean that it's not necessarily a rectangle, a square, or a rhombus, right? You have to look at the actual description because it could say, hey, here's this parallelogram. If all the sides are equal, then maybe it's a square or a rhombus, right? The only difference between a square and a rhombus is a square has 90-degree angles, a rhombus doesn't. But everything else is the same. It's still 2 parallel sides. It's still equal sides, right? All the sides are congruent. The only difference is a square has all sides and angles that are equal. A rhombus just has all the sides are equal, but the angles are different. Okay, so that's one thing to note. All right, let's just do a couple of these examples then. So for number 1, again, this is basically just using your knowledge to figure out how you solve these. Remember, anytime you want to solve for a variable like x or y, you need to make an equation. So you're basically just using your knowledge to figure out how can I write an equation that has x and y in it. So for 3x, right, if I look at this shape here, obviously this is either a square or a rectangle. Okay, but regardless, I know that these are all going to be right angles. Okay, so if those are all right angles, then that means that they're all 90 degrees. So that means 3x, that angle there, has to equal 90 degrees. Same thing for 4y. That angle, 4y, has to also be 90 degrees. I can very easily make an equation for each of those, and then again, it's just algebra. You're just solving to figure out what x and y are. Okay, so I'm going to solve through that really quick. So that gives me x equals 30. And then for y, I divide by 4. I get y equals 22.5. Okay, so relatively straightforward, right? There's not a whole lot to it. It's just you have to know how to identify which angles are equal and all that kind of stuff, and then you're just solving using your own algebra. You just have to basically write the equation yourself. Number 4, okay, I'm going to skip a few of those. I'm going to number 4. I picked number 4 because there actually is not a single angle that they tell you the exact number for, right? So technically, when I'm looking at this, there's not any way to be like, okay, well, if this angle is 50, the other angle is 50, and so on. I have no idea what any of these angles are, right? But the one thing that we do know, if you go back up to the top of the notes here, is that those angles that are next to each other are supplementary, which means these two angles here are supplementary. Now, these two are also supplementary, but if I say 6x plus 3y equals 180, that doesn't really help me because now I have x and y. I don't know either one of them. I can't solve if I have 2 variables. So I have to just use those two, and then I can make an equation because then I can say, all right, well, I know that this angle, 6x, plus the other angle, 12x, have to add together to equal 180 degrees. And from there, it's just algebra. You're just solving an equation for x. Okay? I would combine my like terms, giving me 18x equals 180. And then I just divide by 18, which gives me x equals 10. Right? Simple enough. So that's x. Now, I have to use that to then give me the other angle. Now, one thing that would be helpful, right, is once I know what x is, the other thing to remember is that these angles opposite each other here and here, those angles are the same, right? So if I can just figure out what this angle is, then I can use that to solve for y, right? So then I would say, okay, well, if that angle is 12x and x is 10, this is just 12 times 10, which means that angle is 120 degrees, right? Well, if that's 120, this one's 120. And now I can make that into another equation, right? Because now I know that that angle 3y is just a 120 degree angle. And all I need to do is, again, the same thing. I'm just doing algebra. I just solve to get my variable by itself by dividing. So I get y equals 40. And that's it. Okay, again, there's really not a whole lot to it. It's just kind of using, I don't want to say common sense because it's not like some just common knowledge that you're just going to pop up out of nowhere, but it's just using those basic properties of each of the shapes to figure out how can I make an equation that I can solve for whatever they're asking me to solve for. That's the main thing that you have to really keep in the back of your head when you're doing this stuff is you just have to write an equation. So all you're really trying to do, your work here is how can I write an equation? What information can I use to make this equation? All right, last one I'm going to do is number 5 on this side, because number 5 is a little bit different as well, because notice they kind of drew a line through here and split it into 2 triangles. Now, usually you could try to do something with that, but in this case, I'm not really going to sit here trying to make anything out of these 2 triangles. I'm just going to treat this as one big parallelogram. You could do something with this with the whole triangles and put in the different angles there, but I'm not even going to start trying to worry about that. Okay? Only thing I'm going to do here is I know that this angle, the whole thing, not just 60 or 55, that whole thing is equal to this whole angle. And then this angle down here is equal to this one. So technically 5x and 2y, they're the same. Problem is I don't know what either one of those are. The only thing I do know is that the other angle of that parallelogram is 60 and 55 combined, which means if I add those together, this angle is 115 degrees, which also means this angle down here is 115 degrees. Right? Once I know that, you're doing the same thing like we just did here, right? Because once I know that that's 115, I also know that when I add, for example, these 2 angles together, then it ends up just being 115 plus 5x equals 180 degrees. And then I just solve my equation. And I can do the same thing down here. Right? Because it's the same angles effectively, so it's still 115 plus 2y equals 180. All I got to do on both of these is just solve equations. Right? It's just knowing that, hey, those 2 angles add with the other one to make it 180 degrees. And then from there, it's just algebra. It's just solving equations. So I'm going to go ahead and solve through this. So subtract 115. So that gives me 5x equals 65. And then I just divide by 5. And I get x equals 13. Okay. And then you do the same thing on the other one. Most of the math, the math to start with is actually the same. So it shouldn't be anything too complicated. So minus 115 gives me 2y equals 65. The only difference really on this one is, yes, you will get a decimal, and yes, that is okay, right? So minus 32.5. And that's it. So none of the math on any of these is really anything too crazy. It's fairly basic equations, so it's all still just algebra. The only thing you really have to do is be able to look at them and know like what you're going to do to write the equation, right? Whether they're adding to equal 180, whether they equal each other, or whatever. Okay. Now, go on the back side. So on the back side of this, it's talking about the diagonals, right? One thing that you need to make sure you understand about diagonals is they go from the vertex, right, which is just the corners of the shape, all the way to the other corner, right? So these lines here are the ones we're talking about. One thing you need to understand about those diagonals on any parallelogram is they bisect each other, right? What that means is they basically just cut each other in half, right? So this line AC cuts this line DB perfectly in half, right? So that's one thing you need to understand, which means if it cuts it in half, this part here is equal to this part here, which is what it's telling you right there, AP equals PC. And then the same thing for the other side. DP is equal to PB. All right, so you need to understand that, right? These are equal, these are equal. So that means if I was to ask you or tell you, hey, AP is 10, and I just asked you what's PC, well, PC is also 10, right? Or if AP is 20, PC is 20. If AP is 50, PC is 50. Now, on the assignment, it won't be quite that easy. It will be slightly harder. Instead of saying, hey, AP is 20, what's PC? They're going to say, hey, AP is 20, what is AC? The whole thing. So what would that be then? If AP is 20, what's that whole line? 40, right? It's just doubling it, right? Because it's just two of them. Okay? It should not be that hard. I promise you, and you might think I'm kidding, but on the assignment, I ran through like 5 examples of each skill. One of the skills, that's literally all you're doing. They say, hey, here's this measurement. What's the whole line? Okay. Now, one thing to note on here, there will, and you might want to add this on your notes because there's not anything about rectangles on your notes. But on the assignment, they might give you a question where they give you a rectangle and they have these diagonals on the rectangle, which I don't know why I drew them in red. Okay. They have these diagonals on the rectangle, right? And they'll say something like, all right, so this part right here is 10, and they want to know what is this opposite line right here. Okay, and then you're like, well, how am I supposed to know that? So one thing that you need to understand about the diagonals of a rectangle, right? So on a rectangle, the diagonals are congruent. Okay, so what that means is basically all of these parts are the same, right? So unlike the parallelogram where just this one line had these two halves the same and these two halves the same, right? On a parallelogram, you need to understand that this line here is not necessarily equal to this one over here, okay? More than likely, that blue one would have been longer because it's a bigger angle, or yeah, smaller angle there, so they're further apart, okay? Whereas on a rectangle, both diagonals are exactly the same. So if I know that this part's 10, all the parts are 10. So whichever diagonal they're asking about, they're both just 20. It wouldn't matter at that point, right? So that's one thing you need to know whenever you do your assignment, is that for a rectangle, both diagonals are equal, okay? What else? Oh, the other thing to note is that the triangles that they create are also equal. Right? So if I'm looking at this parallelogram, that means that this triangle here, ACD, right, which is this bottom left one, is equal to CAB, or ABC, however you want to look at it, right? The one above it, right? Or if I go top left to bottom right, doesn't matter, right? But basically it's just saying this triangle is congruent to this one, or this triangle is congruent to this one, okay? The one thing that will be helpful too is also knowing that these triangles that it creates here, so like this triangle is equal to this one, and this one would be congruent to that one, right? So all of those triangles, you can relate them in that manner. They're not all exactly the same, right? You can't say all 4 triangles are equal, because obviously if I look at this, I can tell that these top and bottom ones are a bit more wide, whereas the left and right ones are a bit shorter, okay? That's because it's a parallelogram. On a rectangle, whoops, did not mean to move my whole page. On a rectangle, okay, it's the same thing, right? The top and bottom are going to be longer than the left and right, okay, but they're still congruent triangles. All right, so let's go through a few of these examples and then we'll be done. I'm just going to do like 2 of these. So on this first one, again, you're just using the information that you have to write an equation to solve for x or for y. All right, so if I'm looking at this and I was to label the things that they gave me, well, I know that this side and that side are both equal, right? Because they are the same diagonal. I know the diagonal is just cut in half. So if that side's 12, then the left side's 12. So if I wanted an equation with x in it, I would just say that that 3x is equal to 12. Right? And then from there, it's just solve for x. So divide by 3, x equals 4. Done. All right, solving for y is basically the same thing. It's just different numbers. These diagonals, or sorry, that diagonal, right? You have 8, which means the other side is 8 as well. So I just set 4y equal to 8. And then I solve my equation. So divide by 4, y equals 2. Fairly straightforward. Okay. Now, the other example I'm going to do is number 5, because this is one where it's not quite as straightforward. Okay, because this time you're dealing with the angles. So on this question, the one thing you need to make sure you understand is when I'm looking at this, right, I need to kind of use other prior knowledge that I have as well. So for example, 3x, since these both have this little line like this, that means that this left side is also 3x. That means that these two sides are both congruent, so this is 12 and that one's 12. Well, if you remember from last unit, when we have a 90-degree angle, and it is an isosceles triangle, which means they're both equal, that is going to be a 45, 45, 90. So this is 45 degrees, this is 45 degrees, and that's a 90-degree angle. Okay, well that helps me with solving for x, right? Because that means 3x is just equal to 45. Right? So divide by 3, x equals 15. So x is done, right? Just by knowing, hey, it's a 90-degree angle, it's an isosceles triangle, 45, 45, 90. Done. Now, solving for that other side, the one thing you would need to keep in mind is that those two triangles on left and right are the same, right? So that means that technically these, the left and right side of the parallelogram are the same. This side is also 12. So you got 12 here, 12 here. The only thing I need to figure out is what is this side going to be? Okay? And if you remember from our last unit, when we talked about those special right triangles, right, and I'll even draw it here. So when we talked about our special right triangles, when you had a right triangle that was 45, 45, 90, these two sides were x, this side was x square root of 2, right? That was what we learned last unit. Well, if that's the case, on this triangle, x would be 12, right? Because you have 12 on both sides, which means this side right here is just 12 square root of 2, right? Because it's just 12 with a square root of 2 attached to it. So I would put the same thing here, 12 square root of 2. So now I can make that as an equation as well, right? Now I have 2y equals 12 square root of 2. And then I just solve my equation. The only thing I got to do is divide by 2, which gives me y equals 12 divided by 2 is 6. You do not divide the square root by anything. You just leave it. Square root of 2. That's my other answer. Okay, so again, that one's a little harder because it really kind of requires you to remember some stuff from last unit about the special right triangles. But again, even if you didn't remember that, one thing to remember if you have a right triangle, just use Pythagorean theorem. A squared plus b squared equals c squared. You could have done that as well. You would have solved, gotten the same answer. Okay. The bottom part here we're not doing because you don't do proofs, and I'm not sitting there graphing some coordinate thing on a piece of paper with no grid, and it's really small space, so you won't need that for your assignment anyways. So that is it. So y'all should be able to start on your assignment now.